Hello friends, my name is Ahmed. Welcome to NDT and Quality YouTube channel. So friends, in today's video, when you do film interpretation in radiography testing, that is, we do RTFI. Radiography testing, film interpretation, at that time you must have heard two words in the RT film, contrast and definition. So what is the difference between these two words? That means what is contrast in the field of radiography and what is definition? Right? So it is very important to understand the difference between these two. I have seen many people who do RTFI who call contrast as definition or definition as contrast, etc. Okay? So this is wrong. Generally, contrast shows the density difference in your film and definition shows sharpness. Okay? So here in this video, apart from this, how do you differentiate it and what are the factors due to which the contrast can change? The definition of the film can change. Okay? So we will see both of these in detail. What is the difference between these two? How do you see in the film whether the contrast is good or poor? How is the definition? I will also tell you how to see it. So if you have not subscribed to our channel yet, then definitely subscribe to the channel. Share this video with your friends and colleagues. Apart from this, you can take membership of our channel by using the join feature. I have made many member exclusive videos, in which I have mainly covered the entire syllabus of NDT Level 2. Apart from this, I have also made videos of interpretation of some core and standard. Apart from this, you will also get access to some practical videos of NDT. For example, if you are going to do PCLUT, etc., then I have made videos of practicals of PCLUT which will be very helpful to you. So, to get access to all these videos, you can use the join feature and support me financially. Now, first of all, what is the need of definition in radiography testing? So, what happens in radiography testing? So industrial radiography means that radiography testing film is the type of photographic film that is used in non-destructive testing to detect faults and defects in materials such as metal, concrete and composite. So, when we do RT here, what materials can be in it? It can be metal, concrete or composite. In this, we do radiography. Here, your film is a type of photographic film that you have to use on it. Whatever material you have, whether it is metal or part, whatever, its image will be formed. Okay? And if there is any defect in it, you will get it. The film is coated with a layer of silver, halide crystals that are sensitive to X-rays and gamma rays, and when exposed to radiation, these crystals are changed into metallic silver, creating a visible image. So, the silver halide in it, its final name is silver bromide. It is made of silver bromide. And whenever X-rays or gamma rays etc. fall on it, it will get exposed, and the crystal that remains, that is silver halide, will convert into black metallic silver. So I have made a separate video about which layers are there in the film, and how the film etc. is exposed. So you can see this by going to the RT playlist of radiography. Okay? Finally you will get the visible image that you want to see. Now the image that you see, that is, what is the sensitivity of your radiograph? So it will be called radiographic sensitivity. It is a general and qualitative term referring to the size of the smallest detail that can be seen in the radiograph and to the ease with which the images of small details can be detected. Okay? So what is the smallest detail that you can find? Okay, that is called the radiographic sensitivity of any radiographic film. That means you got to see even the smallest detail. That means the sensitivity of your radiography film is good. Phrased differently, it is a reference to the amount of ination in the radiograph. So in other words, you can also say that how much amount of information you can see. Okay, what will be called sensitivity? That is how much information you can see in the film. So even a very small size is visible to you, so the sensitivity of your film is good. Now note that radiographic sensitivity depends on the combined effects of two independent sets of factors. One is radiographic contrast and the other is definition. Okay? So your radiographic sensitivity depends on contrast and definition. Okay? So both of these are independent. Okay? Here the word independent is written. It means that both of these are completely different factors. And by combining both of these, finally you get radiographic sensitivity. It means that whether you will be able to find out even the smallest detail or not, it will depend on your contrast and definition. Okay? So first of all, if we talk about radiographic contrast here, then see in a radiograph the various intensities transmitted by the specimen are rendered as different densities in the image. So here in the specimen, you will see different types of densities. Okay? In the image that you get, you will find different densities. Right? So whatever transmitted image you get from the cement, it will have different density. The density difference is from one area to another. It will show your contrast. Okay? So what will you call radiographic contrast? If you are able to make the density difference equal. Now this is the radiographic density. Remember that you do the measurement with a densitometer, okay? That type of density means you can do the differentiation between black and white, okay? So your radiographic contrast is good, okay? So you should get the density difference. In simple words, radiographic contrast is defined as the difference in density between any two selected portions of the radiograph. Okay? So when will your contrast be good? Whenever you take any two densities of the film. So you take a black portion and the one next to it and the light portion next to it. So you can differentiate the dark and light portion equally. So you can see that this area is light and this is dark. So your radiography contrast is good. Okay? So you can see here that I have applied two films A and B, so in this film you can see that this defect is easily visible to you in black color. And the background around it is quite light. So you can easily differentiate between the two. Whereas if you look at the film B, you can see the image here. Is this okay? The image of the defect is visible, but the portion around it is also quite dark. Okay? So you can say in this that the density of your defect and the density of the parent metal around it are almost the same. Okay? Meaning that the contrast in this is less. It is poor contrast. Whereas the film A here has higher contrast compared to film B, okay? So in film A you can differentiate differently. Meaning you can differentiate between black and white easily. Above film A has higher contrast than film B. Now how will the contrast change here? Meaning how will it be less or more? How will we know? What are the factors? So see here with these appropriate limits, the greater the contrast and density difference in the radiograph, the more definitely various details we will stand out. Okay? So as the density difference here increases, okay, the density difference will be more in any film. Meaning if the contrast is good, then finally whatever detail there is, small details, a lot of details, we will be able to capture all of that. Definitely we will get that detail. The contrast of the film is good, so it is very good for you. You will get all the details in the film. Okay, now see, here is an example. However, if the overall contrast is increased too much, what will happen if you increase the contrast too much? There is an actual loss in visibility of detail in both the thick and thin regions of the specimen. Okay? So here, there is any specimen which has both thick and thin regions. Okay, this is what we are talking about. I mean, there is a specimen, like your job of casting etc. In some specimen, the thickness of some area is less. In the same specimen, the thickness of some area is very high. Okay? So when you do radiography of the casting, then this problem comes at that time. If you increase the contrast too much, okay, then this problem will come. So there will be an actual loss, there will be loss of contrast visibility. How? The thick section will be imaged and density is too low. Okay? That means the density of your thick section will be very low. That means the image will be very light to be useful and the thin section at density is too high to be viewed on available film viewers. Film viewers will come in such a film viewer. Okay? So where your thin section is, there will be very high density. That means the thin section, which means the thickness is less, your density will be very high there. You will get a very dark image. Okay. This principle is fully illustrated in the figure below, which shows the two radiographs and the steel step wedge. Okay? Below I will tell you two radiographs of the steel step wedge are given here. You can see this. Two radiographs like A and B are given. These two radiographs have been taken at different kilovoltages. Now one, that is, the one with A is exposed at a high tube voltage. Okay? Meaning, this left radiograph is taken at high kilovoltage. Okay? So you can see in this that it is written that the film A is taken at 220 kilovoltage. The film B is taken at 120 kilovoltage. This is an X-ray film. Okay? And the other B is at low voltage. It means that in the middle turns the differentiation in the steps is greater in the low voltage radiograph. Graph B means okay? In the middle radiograph, there is different density. In the middle term, there is a low voltage radiograph. You get good differentiation in it. Okay? You see this middle tone. Middle tone means you see these three. Okay? Compare these three. You can see in BC this portion and this portion. The differentiation between these two is good. Meaning this is dark. In comparison to this is very light. Okay? Whereas here, look, in A, it is dark. In comparison to this, it is less light. Okay? It is less light. You can compare in B, so, in B, we got a good difference in density. We are talking about the middle portion. Okay? Middle means this portion, we can compare in it. So, what will we know from this? That in 120 kilovoltage, there is a middle portion. In that, you get a good density difference. Whereas in high voltage radiograph, A is near the end. Okay, and wherever the step is seen in A, it is much less in B. Okay, so where is the end portion? Okay? So, in the end portion, you will get a good image of A. End portion means this portion. You can compare both of them. Okay? So, in this, you can see, I will take it out here. Look, you have to compare these two. This is the end portion. So in this you can see that the density difference between this one and this one is very less. Okay? That means you will not be able to differentiate these two. Whereas if you see this left portion of the film, then you can easily differentiate between this portion and this portion. That means black and this is a little black and this is light. You can easily differentiate. Whereas in this B film, what happens is that both are almost the same as you can see. Okay? So it becomes easy to differentiate where the endpoint is. When your kilo voltage is high. By the way, here also you can see that this end one is also the end portion. Okay? If you compare these two, then you can differentiate between these two. Whereas both of these are looking almost dark. Okay? So you will get a clear image in this. Okay? Now the second term here is your radiographic film definition. Okay? What is in definition? So sharpness of any change in density is defined definition, and in other words definition is the line of demarcation between areas of different density. So here you can see the difference in density, but how sharp you can see it. Okay? How sharp you can see the difference in density is called radiographic film definition. So in simple language it can be called line of demarcation. Okay? That means whenever you get any indication, then you can see the difference between black and white. But how sharp the line in between it is appearing to you. Okay? How sharp you can see the line is called definition. See, there is a figure of this here as well. You can see that here both A and B are films. Okay, both are films of the same indication. But look at this film. Here you can see the difference between black and white. The definition is okay. But here this image is quite fuzzy, meaning it is not sharp. You can see its end. How fuzzy it is. Okay, look at the end of the indication. So this film is quite fuzzy, meaning it is not sharp. Line of demarcation between this light area and this dark area. The line of demarcation between them is not sharp. Whereas look at the B field, a very sharp line is visible in it. You will be able to differentiate between these two easily, meaning the difference of density between this light area and this dark area. You will be able to differentiate between them easily. So whenever you have to find the length etc. of the indication, okay? You keep a scale etc. on the film, then this one, you can easily take its length etc. from here. Okay? So the definition of the B film is a good definition, whereas the film A has poor definition. So in the above figure, film B has higher definition than film A, okay? So film B has good definition. Here the definition of the film also depends on the greenness of the film. How is the greenness of the film? Okay? You must have heard the name fast film or slow film. What is that? See, these grayness also affects the definition of the radiograph. Grayness is the visible evidence of grouping in clumps of the mini silver particle grains that form the image on the radiographic film. So your film is made up of small silver particles. Silver bromide, which I discussed earlier, okay? It is called green. Okay? So how is the grouping here? Is this silver bromide particle a large particle or a small particle? Its grouping happens accordingly. Okay? So you will get to see the definition according to that. So the size of the particle is large. Suppose, okay? So here you will get poor definition. Large grain is large. Grain is large. So because of that you will get poor definition. Whereas suppose it is small grain. Okay? So you will get good result in the image. Meaning you will get good image. You will get good definition. So look here in this film, the one on the right side has small grain. You can see this. This is your small grain. Whereas the one on the left side has large grain. So, you can see the film of large grain. In this line between underexposed and exposed is fine. It is very less visible here. Whereas, in small green, this line between underexposed and exposed, you can easily see it in the film. Here you can differentiate this line easily. Okay, you can see this, you're getting the line easily. Whereas, in the one on the left side, this line is not available. Whereas, in the one on the right side, this time is available. Okay, so there is a small green structure. This is actually called slow film. Meaning, it will take more exposure time etc. But the image will give you good definition. Whereas the film on the left side is your fast film. Meaning, the exposure time in it is less and you get the image quickly. This will be called fast film. Whereas in the one on the right side, your exposure time is more. This will be called slow film. Okay. So small grains means that this is called slow film, which is on the right side. Provides better definition because they can better outline small areas of film. Okay? So you will easily get small areas in it. That means the definition is good in this case. Large grain means that it causes blurring of the outline discontinuity in fast film. So where there will be large grain, that is, fast film which we saw on the left side here, you will not find this line in it. It is very difficult to find the line of demarcation. Okay? That may cause blurring of the outline discontinuity, so it will show blur. The outline of the discontinuity will appear blurred to you. Okay? So you have to keep this in mind. So these two things, contrast and definition, work in this way. So whenever you give a level 2 or level 3 exam in RT, especially a level 3 exam, then a lot of questions related to contrast and definition are asked. Okay? Right now I have told you which factors affect contrast and definition in this. Okay? I have not discussed that much and I will make a video of it. So many questions related to it are asked in the level 3 exam. So I hope you understood this video. If you have any doubt in this, then you can ask me in the comment box. Okay, thank you.